And the first of all, what is polarization of the light? So students, what is polarization of the light? See, as we know, the light is nothing but an electromagnetic wave. And in the electromagnetic wave, there is a two component basically. There is electric field and magnetic field, in which we generally talk about the electric field. I will tell you the reason why basically we don't in general talk about the magnetic field. I will tell you. In general, we will talk about the electric field. So what is the polarization of the light? Polarization of the light refers to the orientation of oscillation of electric field vectors in a light wave. Basically, polarization will tell us on the basis of that how the electric field vector basically oriented or giving the oscillation. In this way, basically we can say that light is polarized or not. Question number 2. Why the electric field only? Why not the magnetic field? Because in the EM wave, the both are having basically present in a good manner. That's the electric field and magnetic field, both are present. So why basically we are taking only the electric field into the consideration? See, as you know, the speed of light basically you can write at that the amplitude of the electric field divided by the amplitude of the magnetic field. I hope you have must study this, right? Look at this. If you want to find out the amplitude of the magnetic field, it will be written something like this. B naught is equals to E naught by C. What is C here? C is nothing but a speed of the light. That is given as 3 into 10 raised to the power 8 is a E naught. So when you solve this one, you will get approximately the amplitude of the magnetic field approximately of 10 raised to the power minus 8 Tesla. This is a quite low. This is a quite low, okay? And this is one of the reason why basically we don't talk about the magnetic field in the polarization. We generally talk about the electric field, okay? So what is the polarization? It refers to the orientation of oscillation of the electric field vector. So the thing is, if the electric field oscillation we are considering, then the oscillation can be in any direction, any random direction, or any particular direction also. Okay. So in this league, as I said, the oscillation of the electric field can be in any random direction or any particular direction. On the basis of this, we have characterized basically the polarization of light into the 4 types. One is unpolarized light, other is plane polarized light, circularly polarized light, and the elliptically polarized light. So first is unpolarized light. Oscillation occurs in all the direction perpendicular to the wave propagation. That means there is no fixed direction of the electric field vector. It is the random. When the जो हम generally हम देखते हैं ना, जो हमारी जो light ray होती है, these are basically unpolarized light. Its electric field vector are basically in the any random direction. There is no fixed direction of the electric field vector. That's why it's called the unpolarized light. Similarly, the second one is plane polarized light, in which the electric field oscillate in a single plane. If you talk about a single plane, that means let's suppose this is the x component of the electric field, this is a y component of the electric field. So the electric field will oscillate in this either up or down, up or down. It can be something like this, or it can be like this also. Okay, that means it will oscillate in a single plane. So this type of oscillation of the electric field gives the plane polarized light. Next, if we talk about the circular polarized light, then the electric field rotates in a circle around the direction of the propagation, creating some helical path. That means if the tip of electric field vector, if spanning some helical path, that means the motion of the circle, then that type of light ray, that type of light basically known as the circularly polarized light. And you can see the direction of the electric field vector. See how basically we can say it will be anti-clockwise or clockwise. This is a different scenario. I will tell you in the upcoming videos how basically you can recognize whether the light will move in the anti-clockwise direction or the clockwise direction. It's a completely different scenario. Just in this video, I'm telling you that if the electric field, tips of the electric field rotates in a circle, then it will give you a circularly polarized light. Okay. The last is elliptically polarized light. In a one more way, the electric field vector can be basically span in the space, and this is the form of ellipse. So if the electric field describe an ellipse in the plane perpendicular to the direction of the propagation of the light, okay, then we can say that this particular light is a elliptically polarized. Okay. So these are just some brief description about the polarization of the light and different types of polarization. But sir, okay, it's fine that theoretically we can know, okay, this is a plane polarized, and if the tip of the electric field basically rotating in a circle and making a helical path, we can say, okay, it is a circularly polarized light. But how mathematically we can know this? Is there any way? Is there anything? Is there any recognition? How basically we can know about the whether this is a plane polarized, this ray is the circular polarized or elliptical polarized? Yes, it is. Just looking at the equation of the electric field, you can tell, okay, this is a plane polarized light, this is a circularly polarized light or elliptically polarized light. And we will discuss this in our second video, okay? So in the upcoming video, in the next video, I will tell you that how basically you can get to know that just by looking the equation, just by looking the phase factor, okay, this is a circularly polarized or elliptically polarized or plane polarized light, okay? So students, I hope this series of video will be quite useful for you. Just be with this, okay? And any comment from you is really highly appreciated. Thank you.